All right, welcome back. This is part 2 of a unit that I started previously. And so if you have not seen part 1, or I probably called it day 1A, and now we're moving on to day 1B. That's probably how I'll call it. But we are talking about geometric sequences, and this is the model that we are working with. If you want to write a rule for a geometric sequence, then you're going to need two things, the first term and the common ratio. And in video A, I explained thoroughly how to find the common ratio and what it all means. So again, please make sure you watched day 1A before you watch this video. Okay, because basically we did problems 1 through 10 from this lesson, and now we're picking up with number 11. So our goal is going to be to come up with an equation for this geometric sequence. We know there's a geometric sequence, and we're supposed to write the equation. Now, it works like this. The rule for a geometric sequence is always going to be in this form. And there are two things that we need. We need the first term, which is called A1, and we need the common ratio, which is called R. Now, for these two problems I'm going to be doing now, I'm going to give you the common ratio, and I'm going to give you one random term in the sequence. And from that, you should be able to figure out what the rule is. Now, so if we need A1, the first term and the common ratio, if I give you the common ratio, then we're halfway there. So I gave you that the common ratio is -2. So all we really have to do is find A1. So that's kind of our goal. So let me write that down. We are going to find A1. Okay, and here's how we're going to do it. Let's substitute in everything we've got. So AN, we have an A value, it's A3. So we will go ahead and put A3 for now. And that should equal A1, which we don't know, times -2, because that's a common ratio, to the n minus 1 powered. Look, we know what n is. If we're talking about A3, that means n is 3. So it'll be 3 minus 1. See, this is n and this is n. These will always match. If it's A3, n is 3. If it's A4, n is 4, and so on. So we should be able to find A1 from this because we know what A3 is. A3 is 16. Now, I'm going to go ahead and put in 16 now. Now, you might wonder why I didn't just put 16 in the first place. And I could have, but the reason why I like to put A3 at first, because I got the AN, that leads directly to A3, it matches, and it reminds you to put 3 here for n. That's why I do it. Anyway, I can keep going. So this is going to be -2 squared, because 3 minus 1 is 2. And I can actually go ahead and do this. So this is going to be 16 is equal to A1 times 4, because -2 squared is 4. And then, of course, I will divide both sides by 4. So that is going to give me that A1 is 4. Okay? So, look, I had R right from the beginning. Now I have A1. Those are the two things you need to write a rule. So now I should be able to go ahead and do it. So here's the rule. Alright, I told you it's always in this format. And the two things that I needed were the first term, which goes here, and the R value, the common ratio, which goes here. So this would be the rule. Alright, now there's one other part to the directions though. If I look back at the directions, we're supposed to write the rule for the nth term, but then we're also supposed to find A6, the 6th term. So I think the easiest way to find that sixth term, A6, is to use the table function of your calculator. So we are using the TI-30 XS multi-view. So I'm just going to put this in the calculator. So on your TI-30, hit the table button, and let's just type in this equation. So we had 4 times negative 2 to the n minus 1 power. We'll just do x minus 1. All right, and let's just start off at 1 and get to the table. So here's a table of values. Now, right away, this helps us check our answer, which is always good to do. If we have the right rule, then these y values should be the first 3 values of the sequence: 4, -8, and 16. If I look back, oh, you know what? I just remembered we can't check all the values, but we're only given one value. We're given A3 is 16. So if these are the right values, then the third value should be 16, and it is. So that's a good indication that we have the right rule in place. If I want to find A6, the sixth term, I can just scroll down and I see that the sixth term is -128. So I think that's about the quickest way to do that, -128. Okay, all right, let's do number 12 same way. Now if I were you, if you're just kind of watching me do this, I would pause the video right now and try to do number 12 on your own. All right, and then start the video again and see if you got the right answer. So go ahead and pause the video now. All right, so looking at number 12, once again, we're given one term, the fourth term in this case, and we're given the common ratio. And we should be able to use that to find the rule for this geometric sequence. We need to find these two things, the first term and the common ratio. One of these two things we're given straight out. In this case, we're given the common ratio right here is -1/4. So we can go ahead and just plug that in. So -1/4. So this is what we have so far. All we have to do is find A1. That's all we have to do, and then we'll plug that in and we'll have it. How do we find A1? We plug in the other piece of information that we're given. We're given A4. So instead of AN, I'm going to put A4. So A4 is equal to A1, and then we've got -1/4. Okay, now we know what N is. These match. So if this is 4, then that means I'm going to do the 4 minus 1 power. So this is going to give me A4. Well, okay, I'm going to go ahead now and substitute in, because I know what A4 is, all right? A4 is 1. I just wrote A4 to remind me to put 4 here for N. But now I can go ahead and substitute in. A4 is 1. Okay, I got that from right here. And that's going to equal -1/4 to the third power. I just did my 4 minus 1. Okay, so I can solve this. If I go ahead and do the third power, so I'm going to have 1 equals A1 times. Now look, if you do a negative number to the third power, it's going to stay negative. 1 to the third power is just 1. 4 to the third power is 64. Okay, so I'm going to have this. If you did not know that, you could just put it in your calculator. Okay, and you could do -1/4, okay, to the third power. So that gives you -1/64. Okay, so I've got the -1/64. Now, of course, if I want to get A1 by itself, I need to divide both sides by negative 1 over 64. Okay, so I need to do 1 over negative 1 over 64. Now, in the calculator, all right, I can do 1 over, and then I can do negative 1 over 64. I can type it in just the way it is. Okay, that gives me negative 64. Or I could have done 1 divided by negative 1 over 64. Okay, either way you're going to get negative 64. Okay, so we have negative 64 is equal to A1. So look, we have both of the things we need. We needed the R value and we needed the A1 value. We've got them both. So now we should be able to write the equation. Alright, so the equation should be, I'll just go back to the beginning. Now that we know what A1 is, we can just put it in. A1 is negative 64. So this is the rule that we were looking for. We just needed these two values, and now we have it. Again, the last thing we need to do is find out what A6 is. Alright, I think I'll just do that over here. If I want to know what A6 is, I'm just going to go to my calculator. Okay, so go to the table function, and we have negative 64 times negative 1/4, okay, to the n minus 1 power. Alright, let's get to the table, and we want the sixth term. So the sixth term is 0.0625. Alright, that is the answer. Let's see if we can get a fraction out of it. If you highlight that value and hit the toggle key right here, you see that that is 1/16. Alright, if you do not have the TI-30 XS multi-view calculator, I highly recommend that you get this exact calculator. It's only $15, and I'm not a Texas Instruments rep or anything, but it really will help you out a lot, and you're allowed to use it on all standardized tests that I know about. Alright, let's see what's next. We've just got a few more problems. Alright, the next thing we're going to learn is how to write a rule when you're not given the A1 value, but you're not given the R value either. In the problems we've just been doing, I'm giving you at least the R value. This time, I'm just giving you two random terms, and you'll have to find the A1 value and the R value. Alright, so look, if you're not given A1 and you're not given R, we're going to have to modify this formula a little bit so that we can find R and we can find A1. So here's what I want you to do. Instead of writing A1, we're going to put A big. Instead of writing AN. Instead of writing A1, we're going to put A small. Okay, R is still going to be R. Instead of having N minus 1, it's going to be big minus small. So this is the version of the formula that we will need when we are not given R and we are also not given A1. So looking at number 13, we're given A2 and A4. Guess which one of those is A big? That's going to be A4, the bigger one. All right, I'm just talking about the 4 versus the 2. So if I want to set this up, A big equals A small, I'm going to start off this way. I'm going to say A4 is equal to 2. Next comes r. All right, that's what we're looking for right now. And then it should be to the big minus small power. Now remember, 4 is the big, 2 is the small. So we're just going to do the 4 minus 2 power. Remember, the two things we need to write an equation are we need a1 and we need r. So that's what we're going to do. First we're going to find r, then we're going to find a1 so we can write the equation. So by doing this a big equals a small, this gets us this far. Now let's go ahead and substitute in these values. So a4 is 1/5. So that means over here, this is 1/5. a2, that's 5. So that means this is 5. Times r to the 4 minus 2 power, well, that's just squared. So r is the only variable. We should be able to solve this pretty easily for r, and then we'll be halfway there. To do this, let's divide both sides by 5. So if I divide by 5 on, why did I put minus 5? I don't mean that. If I divide by 5 on both sides, so these 5s cancel each other out. So 1/5 divided by 5. Now I know that's 1 over 25, but you might need a calculator, I don't know. So 1/5. Now I can either do divided by 5, like that, or I could do 1/5 over 5, like that. Either way, it's 1 over 25. So this is 1/25 is equal to r squared. Now, how do we unsquare things? We use the square root. Now, you need to know that anytime you take the square root of both sides of an equation, the result could either be positive or negative. So this is not 100% clear. So for right now, when we find this common ratio, please understand it could be positive or negative. Now, the square root of 1 is 1, and the square root of 25 is 5. So this is either positive or negative 1/5. Let's start by just using the positive version. Let's start by, let's just try r equals 1/5. If this works out and gives us all the values that we are trying to find, then we'll just go with that. If positive 1/5 doesn't work, then we'll go back and use negative 1/5. So let's just start off with r being 1/5. So let's see what's going on. So we needed two things. So we found r. Now let's find a1. All right, well, so far, let's see what we have. Here's the bottom line. We know r now. So from now on, if I write an equation, I'm going to go ahead and put the 1/5 in there. So to find a1, I need to start over again using this model. Well, not this model. Okay, I'm going back to this. I'm going back to an is equal to a1 times r to the n minus 1 power. I'm coming back to this. Okay, but this time I know that r is 1/5, so I'm going to go ahead and plug that in. Now, as far as the rest of it, the an, I have two different a values, two different terms to choose from. I can either use a2 or I can use a4. You just have to pick one, and it really doesn't matter which one you pick. Now, I personally am going to choose the a2 equals 5 just because a4 is a bigger number and it has a fraction, so a2 equals 5 just looks simpler to me. So that's why I'm choosing it. Okay, but I need you to understand that when you have two terms like this, it's really up to you. Just pick one and go with it. So I'm going to go ahead and do a2. Now, if I do a2, that means n is 2. So this will become the 2 minus 1 power. So I would write down the a2 for minute. Now, but we know what a2 actually is. So on the very next step, I'm going to go ahead and do that substitution. So instead of a2, I'm going to actually write 5. So 5 is equal to a1 times 1/5. Now, 2 minus 1 power, that's just the 1 power, which is just 1. You know what I mean? So that's just 1, so I don't really need to put the 1, so I won't. So this is what I have so far. Now, I need to get a1 by itself because I'm trying to find a1. So the easiest thing to do is just to divide both sides by 1/5, like this. And see what we get. Alright, now I know that 5 divided by 1/5 is 25. So that's going to be the value of a1. If you did not know that, you could put this in a calculator and you could either do 5 divided by 1/5, then you get your 25, or you could do 5 over 1/5, like that. Either way, you're going to get 25. Now that I have both my a1 and my r value, I should be ready to write my equation. And I'm going to go ahead and put it up here. So since a1 is 25 and r is 1/5, then that's going to give me an is equal to 25 times 1/5 to the n minus 1 power. So this would be a rule that we could use. Now remember, I told you that the r value could have been positive 1/5 or negative 1/5. The reality is, if I use the negative 1/5, I will get a different answer. I'll get a different a value. But the reason is, for this particular problem, there are two different equations that that you could use that would give you the second term of 5 and the fourth term of 1/5. So there are two different correct answers for this problem. Just in case you're curious, the other correct answer would be an is equal to negative 25 times negative 1/5 to the n minus 1 power. This would also fit the information that we're given. Alright, but you just need to come up with one of them. So the blue equation is sufficient. Alright, let's accelerate a little bit, see if we can do number 14, but I need to do it a little faster. So here we go. Anytime you're given two terms like this, you're not given r, you're not given a1, you're just given two random terms, that's when we're going to use this new version of the formula. A big equals a small times r to the big minus small power. So let's see what that looks like. So that's going to look like this. A big is a5. You know what? All right, let's set this up again. So we need to first find r, and then we will find a1. So we are going to be doing a big equals a small times r to the big minus small power in a situation like this. So let's go ahead and find r. So first of all, a big is a5. So that means a5, a small is 2, so that will equal a2, and that's going to be times r to the big minus small power. So that's going to be the 5 minus 2 power. And the reason why I put a5 and a2 here, instead of immediately putting negative 1,792 and 28, is if you put a5 and a2, it'll be real obvious to you that you need to do the 5 minus 2 power here. But we will go ahead and substitute now. So a5 is negative 1,792. A2 is 28. It's right there. And this should be times r to the third power, 5 minus 2. So we need to find r is one of the two things we need. So let's continue. We will divide both sides by 28. All right, does this go in evenly? So that was negative 1,792 divided by 28. That gives us negative 64. All right, so that means that the r value, r to the third, is negative 64. Now we need to know what r itself is, but we've got this third power. How do we uncube things? To uncube something, we're going to need the cube root. Now we learned how to take the cube root using the calculator a long time ago when we were working with spheres. Alright, if I take the cube root of something cubed, I'm just going to get the variable plain r. But how do I do the cube root? I know this answer in my head, but let me show you. If I want to do the cube root of negative 64 on the TI-30, first you have to type in the 3 of the cube root. So we will do that. Now if you look above the caret, you see this x root, meaning any root you want. So whatever number you put here, if I get at this x root by hitting second caret, then that number becomes the root. And I needed to do the cube root of negative 64, so I can just put that in. And that's going to give me negative 4. So the cube root of negative 64 is negative 4. So we found the r value. Now we need to find a1. To do a1, I'm going to go back to this. an is equal to a1 times r to the n minus 1 power. See how similar it looks to the whole a big equals a small? It's really the same thing, but sort of more specific, because instead of just having big and small, I have n and 1. But otherwise it's the same. Anyway, I'm looking for a1, so I need to have everything else. Once again, for this an, you can pick whichever one you want. Can you guess which one I'm going to pick? I'm going to do the a2. The numbers are smaller, and it's all positive. So, but either one would work. So instead of an, I'm going to put a2. A1 is what I'm looking for. R. I know R now. R is negative 4. So this time I'm going to go ahead and put negative 4. Okay? And it's supposed to be the n minus 1 power. So that means the 2 minus 1 power. Alright? So that's how you set it up. Now I know what A2 is. It's 28. So next I can go ahead and put in 28. And this will equal A1 and then negative 4. Now 2 minus 1 is just 1. So that's just the 1 power, and you don't have to write that. So it's just A1 times negative 4. So got to get the A1 by itself, so I will divide both sides by negative 4. Those are gone. And I can see that this is going to be negative 7 if you do that division. Alright, so that means that A1 is negative 7. So look, I've got the two things I needed, A1 and R. That means I can go ahead and write the rule. So AN is going to equal negative 7 times negative 4 to the n minus 1 power. So that is the rule right there. And really, the rest of these problems are all going to be the same thing, kind of over and over again. But you know what? We need the practice. But if I were you, if you've just been watching me do these problems, these last two problems, and not really doing it on your own, you really need to pause the video right now. I've done two problems for you, but you won't really understand it until you do it yourself. So please pause the video and then start the video up again and use it to check your answers. Okay, obviously I don't know if you paused or you didn't, but I hope you did pause, and I hope you have done number 15 on your own. So, but one more time, see if I can go a little faster. Whenever they give us two random terms, I'm going to have to find R, and I'm going to have to find A1. And the first thing I'm going to do to find R, I'm going to go A big is equal to A small times R to the big minus small power. Okay, that is how you set up to find R. So A big, that's A6. So I go A6 equals A small, that's A3. So that should equal R times R to the big minus small power. So that's a 6 minus 3 power. Okay. A6 is 300, so I will substitute 300. A3 is 10, so I will substitute 10. And this is R to the 6 minus 3 power, so that's the third power. Yeah. So now I will divide both sides by 10. So that's going to give me 30 is equal to R to the third power. Now I know that this is going to be a decimal. All right, there's nothing to the third power that equals 30. So there's going to be no way to avoid having a decimal on this problem. So let's just do it and see what we got. So again, to uncube this R, we need to do the cube root, but we have to do it to both sides. Okay, we're doing the cube root. So that's going to leave me with R equals. Now, remember how we type in the cube root. If you want to do the cube root, you have to start with the 3. And then you hit second caret, and it becomes the cube root. So we need the cube root of 30, and bam, there it is. Let's see. So for right now, let's just go ahead and use 2 decimal places. So this is 3.11, let's say. So R is 3.11. So that's one of the things that we needed. Now we need to find A1. Now when we go to do A1, we're going to go back to this version of the formula. AN is equal to A1 times R to the n minus 1 power. We're going to go back to this. Now remember, for these, you get to pick which one of these you want to use. I usually just use the smaller one because it's smaller. So instead of AN, I'm going to write A3, and that should equal A1. Now, I know what R is now. It's 3.11. If I'm using 3, then that makes this the 3 minus 1 power. So this is going to be, now A3. A3 is 10, so now I would go ahead and put in 10. So 10 equals A1 times 3.11 squared, because 3 minus 1 is 2. All right, well, let's go ahead and square that guy. Okay, 3.11 squared. All right, 3.11 squared. That gives me 9.672, but I'll also say 9.67. Actually, no, I won't, because I'm going to have to divide and stuff later. So I'm going to keep it all for right now. So it's 9.6721. So 10 is equal to A1 times 9.6721. Okay? Now I will divide both sides by 9.6721. So if I do that, let's see what we get. So 10 divided by 9.6721 is 1.03. So I'm going to go ahead and round at that point. Okay, so 1.03, that's my A1. So now I have the two things I needed, so I should be able to write this equation. So AN is equal to A1 times R to the n minus 1 power. So this would be the equation for that. All right, last problem. One more is once again the same type of thing. So once again, don't just watch me doing it. Stop the video, do this problem by yourself, and then look and see if you did it right or not. Stop the video now. Okay, you probably didn't stop the video, let's be honest, but I hope you did. It's a better way to learn. Anyway, here we go. One more time. In these problems where we are just given two random values, there are two things that we must do. We must find R, and then we must find A1. When we find R, we find it by using this version of the formula. A big is equal to A small times R to the big minus small power. So here we go. A big is A5, so A5. A small is A2. And that's going to be times R to the big minus small power. So that's 5 minus 2 power. Let's go ahead and do these substitutions now. So A5, that's 3,750. So 3,750, okay, is equal to A2. That's negative 30. Times R to the third power, because the 5 minus 2. So we go ahead and divide by negative 30 to see what is what. So these are gone. Okay, I kind of put the negative sign in the wrong place, but same difference. I need 3,750 divided by negative 30. All right, that's the same as what I have going on here. So that gives me negative 125. So that means R to the third power is equal to negative 125. Once again, if I want to uncube this R, I will need the cube root, like this. And the cube root on the calculator is easy to do. So this is just going to give me a plain old r. And over here I need to do the cube root of negative 125. To do the cube root, I lead with the 3. And then I do second caret, it becomes a cube root. Negative 125. That is negative 5. So the r value is negative 5. I'm halfway there. Now I need to find a1. To find a1, I always do this. an is equal to a1 times r to the n minus 1 power. This is the point where I have to just choose one of these, either one I want. I'm going to go ahead and stick with the smaller, the a2. So an becomes a2 is equal to a1. Now r, I just found r. So I'm not going to write r anymore. I'm going to go ahead and put negative 5. N, I've just decided that n is 2 for now. So this 2 is reminding me to do the 2 minus 1 power right here. So now I can go ahead and do the substitution. a2 is negative 30. So I'll go ahead and put in negative 30 now. Is equal to a1 times negative 5 to the 1 power. 2 minus 1 is 1. I don't really need the 1, so I'm just going to erase it. And I've got this. So I just now need to divide by negative 5 to get a1 by itself. Okay, so that's just going to give me a1 is equal to 6, positive 6. So that was the other thing I needed. I needed the a1 and the negative 5. In my classes today, every time I said a1, my students would go steak sauce. So that is good marketing. Whoever is handling the marketing for a1 after all these years, at least in my class, if they hear a1, the steak sauce just pops right into their mind. So somebody needs a raise over at the A1. Well, I guess it's Heinz Company. Anyway, sidetrack. Back to business. So the final answer would be an is equal to a1, which is 6, times r, which is negative 5, to the n minus 1 power. That just stays n minus 1. So this is the rule that we were looking for. Okay, that is how you do that. Now let me mention one more thing before I sign off of this video. It always is good to have a way of checking your answer. So you might be asking yourself, how could I check my answer? Here's how you check your answer. Use the table function of your calculator and get a table going using the rule that you just found. So go to your TI-30, hit the table button, and type it in. So we have 6, and we have times negative 5. All right, caret, because we need to the n minus 1 power, we'll just use x instead of n. Okay, so there we've typed it in. We'll hit enter. Let's just start off at 1. Just hit enter like 3 or 4 times till you get to the list. Now, what's the point of this? How can I use this to check my answer? Well, we were given 2 pieces of information right at the beginning. And that's all we had to go on. So our answer is 100% guaranteed to be right if it fits both of these data points. So in other words, the second term is supposed to be negative 30. And the fifth term is supposed to be 3,750. If that's true, we win. So let's check it out. Second term, negative 30. Bam! Second term is negative 30. The fifth term is supposed to be 3,750. Chat. Bam! The fifth term is in fact 3,750. That is how you check your answer. Make a table and see if the two values you're given are a match. So this is in fact the correct answer. Okay. 32 minutes long. All right, it might be actually even a little bit longer than that because I paused it and then I started it again. Anyway, this video is plenty long, and it is only it's the second half of the second part of another video that was already like 25 minutes long. So all story told, this has got to be longer than an hour. So I hope you appreciate the effort and the time that I put into this video, and more importantly, I hope it was helpful to you. If so, a like is always appreciated. Give me that thumbs up, helps me out, and I will see you on the next video.